So next we'll discuss liquid drop model. So what is liquid drop model? It is a theory about the size and shape of the nucleus. It was first proposed by Niels Bohr. So according to liquid drop model, the nucleus is considered to be like a drop of liquid. Okay. So, and we know in a drop of liquid, think about a drop of liquid. Inside the drop of liquid there are liquid molecules, okay, molecules of the liquid. So here in this case, inside the nucleus, which is acting like a drop of liquid, has a shape like a drop of liquid, okay, and all the other properties like a drop of liquid. Inside the liquid, drop of liquid, which is the nucleus in this case, there are nucleus instead of liquid molecules. So according to liquid drop model, the atomic nucleus behaves like the molecules in a drop of liquid. In the nuclear scale, the liquid drop, which is basically our nucleus, is made up of nucleons. Just like a drop of liquid is made up of molecules of the liquid, here the nucleus is made up of nucleons, that is protons and neutrons. And it is electrically charged. As we know, the nucleus is this drop of liquid here in this case. It is the electrically charged because the positively charged protons has constant density. The liquid drop nucleus has constant density but varying mass. Its mass may be varying. So the assumptions of the liquid drop models are the following. The first one is that the nucleus is considered to be spherical in shape, just like a drop of liquid. Okay, and the drop of liquid is spherical due to surface tension because of surface tension, the liquid drop tries to occupy the least possible area, and the least possible area is possible only when the shape is a circle, a shape is a sphere. Okay, similarly the nucleus is also spherical, and on the surface of the nucleus there is also kind of surface tension kind of forces are acting, which make the shape spherical. Number 2 is the density of nucleus is independent of mass number A. Just like liquid density is independent of the size of the drop. So if you take water, at a particular temperature, whatever may be the shape of the water, if you put the water in the glass or keep in some other kind of container, or maybe you throw it on the floor, okay, it takes some space, okay, the drop wise, okay. At a particular temperature, whatever may be size of the drop or water drop, it is the density is independent of the size. Similarly, the density of the nucleus is also independent of the mass number A, that is total number of nucleons present in it or total mass of the nucleus. Number 3 is the disintegration of nucleus is similar to the evaporation of liquid molecules from the surface. So during evaporation, we know that if you have some liquid, the liquid molecules absorb latent heat from surrounding and leave the liquid surface to become the gas molecules. Okay. Similarly, during disintegration of nucleus, so when does disintegration or decay of nucleus happens? In case of radioactive decay. So in case of radioactive nucleus, the nucleons leave the nucleus just like the way the liquid molecules leave the liquid surface during evaporation. So this is one more similarity between a drop of liquid and the size and shape of the nucleus. Okay, how the nucleus is built. Another property is that like one more similarity between a drop of liquid and the structure of the nucleus is that the nucleus is supposed to move about within a spherical enclosure represented by nuclear potential barrier, just as the molecules move about within a liquid drop. So we know the molecules within the liquid drop are always in movement, they are always moving, but they never leave the surface unless we supply some heat or they absorb energy from surrounding and they leave the liquid drop the surface by absorbing it and become vapor. Okay. But similarly here the nucleus are also bound to the nucleus. They do not randomly leave the nucleus. Okay. So why this is? In this case the barrier is like a nuclear potential barrier. So in quantum mechanics we have already learned that in one dimensional rigid box there is a particle which is bound within this one dimensional rigid box or infinite potential well. Similarly, so outside inside the potential is maybe very less, but outside the potential is very high, so that the particle do not have enough energy to move to break the potential barrier or penetrate through the potential barrier. Similarly, inside the nucleus what happens that the nucleons are always moving. Okay. But outside the potential they do not have enough energy so that they can break through the nucleus. Okay, so outside the potential energy is very high compared to the potential which is experienced by the nucleons inside the nucleus. So this is one more similarity between the liquid drop and a nucleus. Now one more similarity is that the constant binding energy per nucleus. So for a particular nucleus, the binding energy per nucleon is a constant quantity. It is similar to latent heat of vaporization. So for a particular liquid, the latent heat of vaporization is a constant quantity. You need to supply certain amount of energy to the liquid so that the vaporization start and the liquid molecules leave the liquid surface. Similarly, you need to supply a certain amount of binding energy to the nucleus so that the nucleus come out of the nucleus. Okay, so the nucleus leaving the nucleus is similar to evaporation, and we need to supply latent heat. Okay, so here there will be latent heat of vaporization, and we need to supply latent heat of vaporization to the liquid. Okay, to make the evaporation happen. Similarly, we need to supply binding energy to the nucleus to make this disintegration happen. Another property is that when high energy nuclear projectile hit the nucleus, a compound nucleus is formed which emit nucleus almost immediately. Okay. So when high energy projectile means, suppose there is one nucleus and you hit the nucleus with a target neutron. A neutron comes with a very high speed and hit the nucleus. So in that case what happens? First a compound nucleus, so that the neutron with a very high speed comes, hit the nucleus and get attached to the nucleus, and as a result a compound nucleus is formed which eventually break apart. Okay, it emits different kind of nucleons to become stable, and this happens almost immediately. So if suppose a neutron comes with very high speed and hits some nucleus, it stick to the nucleus forming a compound nucleus, but this compound nucleus will be in a higher energy state and it will become unstable, and to become stable it will emit some nucleons, form a new nucleus, and this will happen immediately. Okay, so all these are properties of nuclear drop model, and depending on the nuclear drop model, next what we'll learn semi-empirical mass formula which will give us an expression for binding energy.